Alright, hello everyone and welcome back to a new TouchDesigner tutorial. It's UV here and I hope you're all doing good. So for those of you who doesn't know, I've recently launched a new costume family operators, which is called POPX. POPX stands for POPs extension, which basically it's a bunch of tools, an ecosystem of tools that are based on the new POPs operators, the point operators. And they allow you to basically control and transform and simulate pop geometry or instances in a more controllable and uh, more, I would say, easy way. Um, so if you haven't experienced with those, I highly recommend you to go to my Patreon and see what I'm talking about. There is also the POPX um, documentation website. So um, there is like a getting started installation guide, and you can uh, look up all the different operators and their parameters and basically what they do. So for example, for the soft body that we're going to use or the constraints, um, yeah. So one thing I need to say is that here in this example, I'm using a new versions of the constraints, POPX and the soft body, and also the sweep operators. So I'm continuously improving and developing new features for POPX. And the next release, I believe, will be coming very soon. But in the meanwhile, I want to share with you like individual POPX operators that I've improved and to share an example of actual things you can do with this. So this example is basically what we're going to look at, and it's basically using the constraints and the soft body. And as you can see, there is like those strings that are attached to the geometry, and then the soft body solver is basically solving them. And you can see that they're moving with the model over here. They have also gravity and some wind forces. So we'll be focusing on creating the actual simulation, which is over here. And it might look a very uh, crazy network, but basically the constraints and the soft body are doing most of the work over here. And then we're using the sweep to create the surface for the strings and just rendering with the PBR material. So we're going to build this from scratch, and you will get this example file so you can see also what I done with the rendering part over here. Um, so yeah, it's also very simple stuff. But we're not going to focus on this because I want to focus on the actual simulation. So for the rendering part, I just have a floor and a back wall over here. And it's a very simple rendering network where I also get the depth of the render top over here, and with the Luma blur, I'm kind of like doing a DOF, depth of field. Some leveling over here, and I'm using also the open color IO to have some lot, which gives a more nice look to the render, the output. So a lot of like post processing, and also um, I'm using the MFI motion blur, which is the free plugin that you can get from the Matterform um, Patreon page over here. So big shout out for him to creating a really nice motion blur that gives this kind of like realistic post processing. So if I will bring it and connect it, it's pretty heavy sometimes. So in the setup or in the blur, the complexity, I would say don't give it like too low values over here, because it's going to be um, pretty heavy on the GPU. But if you have a good GPU, so go for it. So if I connect it over here, I'm not sure if you will see the effect that much on YouTube or whatever you're watching it, but for example, if I increase the amount, so you can see where there is motion, it's kind of like blurring it, and it's a really really nice effect to have. So you will get this also in the example file, so you can just use it also. um yeah, so simple lighting also with an environment light and an HDRI. So you will get the HDRI files also, and some free lots that I downloaded from the web, so you can switch them and render um, how you like, basically. So yeah, let's dive in and basically build the simulation itself from scratch. So I'm going to open a new TouchDesigner project file, and first, for before we get started, um, as you can see, I don't have the I have like a borderless TouchDesigner, which is really nice. So I got this component from Function Store that basically allows you to kind of like make TouchDesigner borderless, and it's pretty cool. So I highly recommend you to also go to the GitHub of Function Store, or its Patreon basically, and search for function store, and it has like function store tools, and in the models there is lots of stuff, free stuff that you can basically download and just use. So yeah, we have this BorderlessTD, which is really nice if you want to record tutorials or any other use that you find from it. Yeah, so let's go to the blank uh, new TD project file over here, and let's start creating our simulation. So I already prepared um, the three constraints, soft body and sweep, the three operators over here, and yeah, basically these are upgraded version of the POPX current released version. So in the next update, everything will be packed onto the this kind of like integrated POPX component. So you won't have the POPX operators over here on the OP create dialog, but you can basically save those for now as a tox file, whatever you want, and just drag it onto your project files. Great. So um, what I wanted to first do is basically import our model, and for that I used the this website that basically allows you to kind of create a simple FBX file, an animated FBX file. So you first can basically go to the characters over here and search for a character. I just simply use this mannequin, and then you can choose an animation to basically apply to the mannequin. So I believe I found something like running or dancing and stuff like this. So you can just click on it and it will apply the this kind of like animation. And simply you just click the download over here, and it's going to download a FBX file. I think you need to log in first before you do this and create an account. And when you will have the FBX, so you will just drop it onto your project. So let's pick the running model. And you will have those, I think in the example file, you will find assets and the FBX files for running or walking, and you can switch between them. So we have our running model over here. Now I want to scale it down quite a lot because it's really big. So I'm going to scale it down with 0.001, and then I'm going to press H to see it. Now what I want to do now is to create an import select pop over here and just reference it over here in the import parent and choose the geometry. And you can see that what happened now is that we have our mesh over here, but it's not animated. So to animate it, we're going to use a skin deform, and we need to kind of like reference the skeleton root path over here, I believe, or maybe, yeah, just reference the skeleton root path over here, so the FXB basically, so it will basically apply the animation. Cool. So let's move it over here. Now what we want to do is to basically scatter some points on the geometry. So I'm going to use the sprinkle, and we have some points that are going to be kind of like the starting points of our strings. I'm going to reduce it to have like 1000. And now I want to copy some lines that will be our strings. So I'm going to make them align to the z-axis like this, and I'm going to use a copy pop and just plug it in like this, so we have our strings, our lines copied. Now what I want to do before here is, first the division, I want to lower it to like maybe 8, so the soft body solver won't you know, work too much. You can play around with those numbers, also the number of points over here, as much as you want and how much is your computer can handle. And also I want to add a group over here that we will call pinned. pinned. So we want to pin basically the first point, or maybe the first and the second point of the line over here, to be pinned to the basically to be constraints onto the geometry. So I'm going to choose by pattern over here, and I'm going to choose the first point index. And if I debug it with the color, not sure if you will see it, but we have only the first point with this color. Maybe you will see it better over here. You can also do like the second point over here if you want. I will go just for the first point. And another thing I want to do is also to rotate them based on the normals of the points that we generated. So we have the normals of the mesh over here that are being passed onto the points. And now our lines, let me just turn off the debug color, and our lines are now kind of like aligned on the normals direction. Another thing that I would like to do is to create, like, to scale those lines randomly. So I'm going to create a random pop, but I'm going to bring it before the skin deform, because it doesn't need to basically cook every time, because I believe this is not cooking, so it will save us a little bit of computation. Because if I will put the random basically over here, for maybe over here, so you will see that it's cooking, not a lot, but like I like to, where I can, to basically save computation time. So I want to set to combine the combine operator, to set it to set, and choose a point scale attribute. So it's going to create random point scale attribute. We want it to be random size just 1, so it's going to be just a float. And I want it to be like 0.1, for example, from 0.1 to 0.3. Let me save it so it won't crashes for a reason. And here in the copy pop, we're going to choose the template scale to be a point scale. And you can see that we have kind of like a random length. Let me split my screen, actually. It will be much more nice to look at the things in the GeoViewer. And here I don't want to render this or display it. So I can play around with the randomness over here as much as I want. Let's keep it like this for now. Now it's time to create our constraint. So we're going to use the constraints over here. The thing about the constraints POPX operator is that it doesn't like where when the input is basically cooking, all right? Because to build the constraints geometry and all the computation that is happening over here, it's pretty heavy. So at default, the input is being locked basically, and you can reload it by pressing the reload over here. So when I will connect it, for example, and what we want to do is to choose the string constraints over here. So it will take some moment to basically generate those. So probably you're going to be freezed over here, but when it finished, it's basically created it. But you can see that it's not updating. Uh, and this is something that is okay, because we're basically we want is to create our constraints only once, and then we can manipulate them after we generated them, right? You can also see if I unlock it over here. So I've pretty much the string constraints are not that high, but for other constraints you can go, you will see like a lot of cooking time over here. So you unlock it basically, and then if you want to change anything on the input over here, you can just press reload, and it's going to basically um, kind of like update any attribute that you're going to change from the input geometry. And I'm going to actually put a keyboard in chop over here to reference the reload over here, so I could do it faster. Now, the problem is that when we look at the output of the geometry, and let me copy the null and also the output of the constraints. So the constraints are generated, right? You can see all the attributes and stuff, and these are lines. But our geometry also contains some information about the constraints, okay? But the problem is that the position is not being updated anymore, or any other attribute that we're going to change over here. So to solve this, we're simply going to add a attribute combine. Oh, whoops, it's automatically connected. So the attribute combine, we can basically um, connect the geometry with all the attributes that the constraints has been created for us. And for the second input, let's do it something like this. I'm going to actually take our copy pop over here, and I'm going to want to grab the positions that what we're aiming for over here, because the positions of this are not being updated because the constraints basically are locking it. So for that, I'm going to set here the duplicate attribute to keep last. Okay, and I'm going to grab the position or any other attribute that you want, basically, from the copy pop over here. So now I have all the data that I need, which is the updated position and all the constraint ID, count, and mass, and other attributes that basically are important for the soft body to solve the constraints. So this is, I'm going to call the geo, and this is the constraints. Actually, let's just do it like this. So this is our setup, and let's move it to here. Now we're ready basically to solve these constraints. Let me close all the viewers over here. And first, what we want in the soft body, I want to reference the keyboard in like that to the start pulse, and I'm going to save again, Control S. And for the soft body, we need to connect our geometry, and the second input, the constraints, and hopefully this will work. By the way, um, the new soft body and constraints are basically working with Mac OS. Hopefully, I've tested it, um, but you should definitely check it. And if you see that it's not working, please give me a feedback on any errors that you're getting. So when we start our simulation, our strings are just flying out down because of the gravity force over here. And we also forgot to basically pin them to our geometry. So for that, we created our pinned group over here. And what we can do is basically go to our constraint page over here. And here we can choose a group to basically pin points to pin to animation. So I'm going to choose the pin point, and what I want to do is there's like three types of pin types. So there is the permanent, there is the stop. So it's basically creating an attribute that you can control during the simulation if you want to kind of like stop the pin or not. And there is like a soft pin, which are basically kind of like a distance constraints to the pin point. Um, so I'm going to choose the stopped. It doesn't matter because I'm not going to basically release them. So you can choose either permanent or stop, or also soft if you want. And the important stuff here is that I would like to match the animation. So what will happen over here, and I think you can see it, is that our pinpoint are going to match the actual positions that we're going to input for our geometry. So only those first points are going to be updated, not based on the solver that updates their position, but they're going to be fixed at the actual position that we're feeding in the to the solver. And you can also visualize your constraints over here. So I'm going to not visualize our constraints, but visualize our, yeah, like this. And you can see in red, we have those, too much. We have in red those kind of like group that we created later, before, over here in the group. So now, if I start the simulation, press 1, you can see that we have our string that are attached, and they are basically they can't fall because they are attached to the geometry. One thing I would like to do here is maybe slow down the simulation, like the animation. So I'm going to go to the FXB and slow it down to, let's say, half. And maybe have less gravity. So I'm going to decrease the gravity multiplier and maybe add some damping. And actually, maybe let's make it a little bit more faster. Right. Now, there's a lot of stuff we can do with the soft body. Let's focus on certain aspects over here. So we can add collision, for example, a ground collision. So you can see that without the ground collision and with the ground collision, let me just click. You can click either Q or just press the adapting to toggle it off. And so you can see that where they are collided with the ground, which looks much more natural when you want to render them later with like a floor. So you will match those ground position to your floor. And you can see that in the forces, we don't have like, wind or any kind of like forces that we want to apply. And this is in purpose because to basically apply forces to the simulation, you need to feed back the simulation to the target geometry update pop. So I'm going to create a null from the geometry output over here, and I'm going to call it target. Now I'm going to reference it over here on the soft body parameter, and then between the output and the target I can apply any force that I want basically. So for that we have a nice pop which is the force radial, and this is basically applying forces. So if I put it over here, you see that we have some radial force, which is I think at the center right now. But what I actually want is a wind. So in the global page over here, we have some wind. And if I increase the wind, I think it's going to the right x-axis over here. But what I will actually want to do is to kind of like have a wind backwards. So I think it's going to be like -1 at the z-axis. Yes, this is what I wanted, but less of the wind. So something like this will be great. Let me save the file over here. And obviously, you can increase the number of strings over here. So if I update it, the thing is that the constraints and everything wasn't really updated. And you can see that we have an error over here, that the number of elements in the block 1 is different from the first input, because what we need to do is basically to reload our geometry onto the constraints. So I'm going to just press 1 and something happened over here. So if I will press 1 again, so it will fix it. This is like a little bug, but yeah. So just press 1 until you see that it's actually running. So now we have more strings, and you can really play around with this. And you can also play around, maybe make them the length larger, and press 1 again. And you can see that they're longer. You can also pass more attributes like color and stuff like this. So for example, I can do another randomize over here and maybe set a color attribute, but I would need also to copy it to our lines over here. So I'm going to go to the template attribute, use template point attribute, and I'm going to copy the color. And here, what I would need to do is also update and pass the color attribute. So now we have random colors on each strings, and you can kind of like play with it, or just use different operator like a noise maybe to generate your color, or basically any other attribute that you want. Um, Now, lastly, um, I think actually before the sweep, I wanted to show you the sweep, but before that, I'm going to remove the colors because I don't like it really much right now. But before that, what I want to do is kind of like apply a bit of a noise to our lines over here, so their initial kind of like position are not that straightforward like this. So for that, I want to bring out a noise, but I don't want the noise to affect the group points that we created over here, the pinned points. So um, for that, what I want to do is kind of like create an inverted group. So I will take a second group over here, and not sure why it's okay. A second group, and I'm going to create a noise group. That's the name of the group. And in the group tab, I'm going to select the pinned and just invert them. And now I'm going to use the noise. And here I'm just going to choose the noise group. So it's going to apply the noise only to our not pinned point, basically. So it's going to skip our pin points and apply the noise. So I'm going to apply it also to the constraints and press 1 to regenerate this. And then we have a little bit of variation. Let me reduce a bit the number of strings over here. So we have a little bit of noisiness, and obviously to show it better, you can increase the number of lines over here and maybe add more iterations to the constraints. Really depends on the look that you want to go for. Um, Maybe play around with the noise a bit. Yeah, something like that. Now, when the noise is too much, it's kind of like because the number of string of points per string is lower. So you can see those kind of like weird edges. So you can connect a line smooth, basically. Oops, a line smooth. So I'm going to connect the line smooth like this, and it will smooth out a bit the sharp edges. So you can also play around with this. You can also resample it over here if you want. But I will go for that for just leave it like this. Maybe decrease a bit the length and restart. All right, so now I want to create like a more of a surface to my strings over here. I want to also reduce a bit more. Let's go with 1000 and Control S for saving. So the sweep, it will create kind of like surface for our strings, so we can basically shade them nicely. But because we have multiple strings, we need to define here um, I think group of n primitives. Let's find out. Maybe it's skip every n primitive. But what I want to do is basically take this divisions, okay, and grab it onto my n parameter over here. And I'm going to also reduce a bit here, maybe even less. And let's see if it works. So again, we reference the number of divisions over here from the line parameter, line pop that we created. And let's display off this and display our sweep. Right, it's kind of working. I believe that we need to kind of make it the number of divisions, but plus one, and this will solve it. And this is because you can see if I see the number of vertices per line, it's actually 17 here. Not sure why. Um, yeah, anyway, the plus one just solve it. I think you can also do, no, not skip. Yeah, it's group of n primitives basically. So now we have a nice surface. So in the rendering part, we can kind of like shade it much more nicer than the lines. You can play around with the width. Whoops. Um, and yeah, this is like the number of columns um, per surface. So like the more it will be more dense and like will look more nicely when shading. But it's more computation. And a nice thing that we can do is to apply a scale along the curves over here. So for example, if I click on it like this, and I can use the ramp, which I said from previous example, but I can reset it. So you can see that at the start of each um, string here we have 0, so it's like squeezing and being small, and at the end it's bigger. I wouldn't go for completely 0 because it's uh, yeah, it's not good. And I think we can also, yeah, no, it's good. So you can play around with this ramp or use just your own ramp and reference it um, over here. Um, but I will play around with this ramp over here to kind of like create the shape that I want. So maybe in the center we'll make it like this, and maybe something like this. Maybe here make the value 2, so we have like nice big like on the edges. And we can also color them. So yeah, it's still actually the colors that I used in the examples, but you can color them also along the curve, which is also really nice to have. Um, yeah, and I think this is it for the example. Um, to render this, basically, um, you can go to the example file and kind of like look how I set up the rendering, and basically playing with the materials and some post processing. But mainly I wanted to show you how to create it um, in the simulation aspect. So I really like this setup because I feel like it's creating a really nice effect with respectively like a very simple network, because the main jobs and the complexity of this operators or this system is mainly the soft body and constraints, and the sweep are basically doing it for you. So you don't need to think too much and just be more on the creative side. For example, applying some more nice forces, you can totally go for a different geometry here generate your own geometry inside TouchDesigner and apply those strings on it. It doesn't have to be from a FBX file. Um, you can go crazy with it, and I would really want to see you take it to your creative mind. And you can obviously use the example file for startup for starting up, and go from there. And I think this is it. Thank you for your support, and for those of you who actually use POPX, your feedback is very helpful for me to improve it, and I really appreciate it, and I really like to see people using it. There's lots of new features are coming, and I'm constantly developing and adding stuff. I hope soon the new release will be finished and I will launch it. And thank you so much for watching, and I will see you in the next tutorial. Bye bye.